ठीक है तो today we discuss about the topic continuity. A function fx is said to be continuous at a point x is equal to a if it satisfies three conditions. First condition 1, f of a is a definite value. The second condition is limit x tends to a fx exists. That is, the left hand limit is equal to right hand limit. Which one already you taught in first year? The left hand limit is limit x tends to a minus fx, which is equal to limit h tends to 0 function of a minus h. And the right hand limit is limit x tends to a plus fx, which is equal to limit h tends to 0 function of a plus h. So then we have to require left hand limit is equal to right hand limit. That is the step 2. And the step 3 is the limit x tends to a fx is equal to f of a. If all the three conditions are satisfied, then the function fx is said to be continuous at a point x is equal to a. If you go to some example here, first one, test the continuity of fx is equal to sin 3x by x if x is not equal to 0 and its value is 3 if x is equal to 0 at x is equal to 0 point. So when we solve the test the continuity, we have to first find out all the three conditions. We satisfy all the three conditions. That is, the first condition is, so first we have to find the value of a here. What is the value of a here? Now a is equal to 0 is given here. A is equal to 0. So at x is equal to a. So a is equal to 0 here. So if you go to the step 1, f of a means f of 0. What is the value of f of 0? Is 3, which is a definite value. So it satisfies the condition 1. Then we go to the second condition, that is step 2. Now we have to verify the limit x tends to 0 fx exists or not. So we have to test this one. Limit x tends to 0 fx exists. So first we have to test find the left hand limit. What is the left hand limit? Limit x tends to 0 minus fx. Already you read in first year, limit x tends to 0 minus of fx. 0 minus fx means its value is limit h tends to 0 function of 0 minus h, which is equal to limit h tends to 0 function of minus h. Already we know that h is a very small positive quantity, so minus h is not equal to 0. Since minus h is not equal to 0, then your fx is equal to, what is the value of fx? Sin 3x divided by x. So f of minus h, what is f of minus h? Sin 3 into minus h by minus h. So what is this value? Limit h tends to 0, sin of 3 into minus h or minus 3h divided by minus h. Then which is equal to limit h tends to 0. Already we know that sin of minus theta, sin of minus theta is minus sin theta, minus sin theta. So sin of minus 3 is minus 3h divided by minus of h. Now h and h are cancelled. Again, already you know a formula in limit. We know that limit x tends to 0 sin x by x is equal to 1. So limit h tends to 0 sin 3h by h is given. So limit h tends to 0, our required is sin 3h divided by 3h is required. So we divided 3 and multiply 3 here. Again, as h tends to 0, 3h is also tends to 0. Then if you apply the formula sin 3h is x, sin x by x, limit x tends to 0, so its value is 1. So 3 into 1 is 3. So its value is 3. So now the left hand limit is equal to 3. Now we also solve the right hand limit. Similarly, the right hand limit is equal to limit x tends to 0 plus fx, which is equal to limit h tends to 0 function of 0 plus h, and which is equal to limit h tends to 0 function of h here. Again, what is h here? H is a very small positive quantity and which is not equal to 0 here. So fx is equal to, according to the question, fx is equal to sin 3x by x here. So what is f of h? Sin 3h divided by h. So now what is its value? Limit h tends to 0, replace here fx as sin 3h divided by h. So to find the limit, already you know the formula of limit x tends to 0, sin x by x is 1. So limit h tends to 0, sin 3h by h. Then what is its value? Then so we have to first multiply 3 and divided 3. As h is tends to 0, 3h is also tends to 0. So its value is 3 into, according to the formula, its value is 1. So its value is 3. Now here the left hand limit is 3, the right hand limit is also 3. So left hand limit is equal to right hand limit. That's why limit x tends to 0 fx exists. And since it is exists, so already you know that the limit, so the limit x tends to 0 fx is equal to, if the left hand limit is equal to right hand limit, that value is known as your limiting value. So limit x tends to 0 fx is equal to 3 here. So 3 is the limiting value of fx when x tends to 0. Now we go to the step 3, the third condition. The third condition is the limiting value, the limit x tends to 0, fx is equal to 3 here. And in the step 1, already we know that f of 0 is equal to 3 here, then which is equal to f of 0. Now here the step 1, step 2, step 3. Here all the 3 conditions are satisfied. Since all the 3 conditions are satisfied, then our fx is continuous at x is equal to 0. That's the function. Then so fx is continuous at x is equal to 0. Similarly, we have to take another example here. Here the question is given, test the continuity of fx is equal to 1 plus 2x to the power 1 by x to the power 1 by x if x is not equal to 0 and its value is e square if x is equal to 0 at x is equal to 0 point. At x is equal to 0 point. So first we take the step 1. To solve this problem, test the continuity, we have to satisfy all the 3 conditions. The first condition is here a is equal to 0 here. In step 1, f of a means f of 0. What is f of 0? Here at x is equal to 0, f of 0 is e square. F of 0 is e square, where e square is a definite value. Then we go to the step 2. Step 2. If we have to show that the limit x tends to 0 fx exists or not. We have to test the existence of limit in step 2. So first we have to take the left hand limit. Now the left hand limit. What is the left hand limit? Limit x tends to 0 minus fx. So what is its value? Limit h tends to 0 function of 0 minus h. And now its value is limit h tends to 0 function of minus h. Already you know that minus h is not equal to 0. Since minus h is not equal to 0, what is the value of fx here? Fx is equal to 1 plus 2x to the power 1 by x. So what is f of minus h? F of minus h is 1 plus 2 into minus h to the power 1 by minus of h, which is equal to 1 minus 2h to the power 1 by minus h. That is limit h tends to 0. We can write 1 minus 2h or 1 minus 2 of h whole to the power 1 by minus h. Since in your limit formula already you know that limit x tends to 0, 1 plus x to the power 1 by x is equal to e. There is a formula in limit. So 1 plus x to the power 1 by x is e. Then what is x here? Minus 2x. So our required 1 by x here. So 1 by minus 2h is required. Since x is equal to minus 2. So now we go to the next step. Limit h tends to 0. 1 plus minus 2h to the power 1 by in minus h minus 2h is required. So multiply 2 and divided 2 here. And what is its value now? Now its value is taken as, or according to the formula it is e. So its value is e square. So the left hand limit is equal to e square. Now similarly we go to the right hand limit. The right hand limit is equal to, that is limit x tends to 0 plus fx. 0 plus fx. So its value is limit h tends to 0 function of 0 plus h. And we know that what is h here? H is not equal to 0. So fx is equal to same 1 plus 2h to the power 1 by h. And f of h is 0. What is f of h? 1 plus 2h to the power 1 by h. Then which is equal to limit h tends to 0. What is f of h? 1 plus 2h to the power 1 by h. Then which is equal to limit h tends to 0. Since there is a formula in your limit h tends to 0, 1 plus x to the power 1 by x is equal to e here. Then what is x here? X is 2h here. So we have to write 1 plus 2h to the power 1 by 2h is required. So divided 2 means we have to also multiply 2. Now there is a formula is here. As h is tends to 0, we also take here 2h is also tends to 0. Here also we also write it 2h is tends to 0. Then so limit h tends to 0, 1 plus h to the power 1 by x. According to the formula is e, which is equal to e square. So the right hand limit is equal to e square. Now left hand limit is e square, right hand limit is e square. Then hence the left hand limit is equal to right hand limit. Then that implies limit x tends to 0 fx exists. Since it is exists, go to the step 3. In your step 3, what is the limiting value? The limit x tends to 0 fx is equal, left hand limit is e square, right hand limit is e square. So that value is your limiting value. And what is f of 0? F of 0 is also e square. So is equal to f of 0. Then now limit x tends to 0 fx is equal to f of 0. Then all the three conditions are satisfied. Then so fx is continuous at x is equal to 0. Continuous at x is equal to 0. Now here, then here the second condition is this one. Then there is a note here. Write a note. Write a note here. That if any one of the condition, if any one of the conditions out of 3, if any one of the condition out of 3 is false, then fx is said to be, fx is not continuous at x is equal to 0. Fx is not continuous at x is equal to 0. Then that is, fx is not continuous means that is fx is discontinuous. Fx is discontinuous at x is equal to 0. Fx is discontinuous at x is equal to 0. Now we have to take an example, another example for not discontinuous function. Test the continuity of fx is equal to given by 3x plus 1 if x is less than 2 and its value is that is 7 if x is equal to 2 and its value is x square if x is greater than 2. We have to test the continuity at x is equal to 2 here. At x is equal to 2. Then here, then at x is equal to 2 point. So first we have to test here at then the value of a. What is the value of a here? A is equal to 2 here as x is equal to 2 here. So a is equal to 2. Then in your step 1, we have to find what is the step 1? F of a is a definite value. Then f of a. A means what is f of a? F of 2. Then what is the value of f of 2? Then f of 2 means what is the value of f of 2? F of 2 means then you have to take your x is equal to 2. Then at x is equal to 2, its value is 7. So f of 2 is 7. Is a definite value. F of 2 is 7, which is a definite value. Now we go to the step 2. Test the existence of limit x tends to 2 fx. So to test the existence, we have to also find the left hand limit and also right hand limit. So what is the left hand limit? The left hand limit is limit x tends to 2 minus fx. Limit x tends to 2 minus fx. And what is the limit x tends to 2 minus fx? That means its value is limit h tends to 0 function of 2 minus of h. And now we have to find here 2 minus, what is h here? Since h is a very small positive quantity and 2 minus h, a positive quantity is subtracted from 2, it must be less than 2 or greater than 2. It must be less than 2. For x is less than 2, what is the value of fx here? Then fx is equal to 3x plus 1. Fx is equal to 3x plus 1. So what is the value of f of 2 minus h? Then f of 2 minus h is 3 into 2 minus h plus 1. Now we have to replace here, that is limit h tends to 0, function of 2 minus h is 3 into 2 minus h plus 1. Now we have to replace here h is equal to 0 here. If you replace h is equal to 0, then 3 into 2 minus 0 plus 1. That is 6 plus 1, which is equal to 7. Then hence the left hand limit is equal to 7. Then here, since left hand limit is 7, now we go to the right hand limit. What is the right hand limit? Limit x tends to 2 plus fx. Limit x tends to 2 plus fx. Then 2 plus fx means what is its value? Limit x tends to 0, function of 2 plus h. Now function of 2 plus h. What is the value of function of 2 plus h? Here 2 plus h is greater than 2 or less than 2. Since h is a positive quantity, 2 plus h means it must be greater than 2. Since it is greater than 2, what is the value of fx here? Fx is equal, for x is greater than 2. What is fx here? Fx is equal to x square. Fx is equal to x square. So f of 2 plus h, what is its value? F of 2 plus h is 2 plus h square. F of 2 plus h is 2 plus h square. Then what is the f of 2 plus h? Limit h tends to 0. Function of 2 plus h is 2 plus h whole square. Now put here h is equal to 0 here. What is its value? 2 plus 0 square. What is its value? 2 plus 0 square means which is equal to 4. Now your left hand limit 7. What is the right hand limit? 4. So left hand limit is not equal to right hand limit. That implies limit x tends to 0. Limit x tends to 2. Fx does not exist. Does not exist. Since limit x tends to 0, fx does not exist. Now your step 2 in the existence does not exist. The limit does not exist. Since it does not exist, then it does not satisfy the second condition. So here one of the condition false, then limit x tends to 0 does not exist means then fx is not continuous. Is not continuous at x is equal to 2. That is f of x is discontinuous. Is discontinuous at x is equal to 2. Okay. So now the discontinuous. So if any one of the condition, there is no need to test the third condition. So here all the three conditions satisfied means it is continuous. Any one is false means it is discontinuous. So now listen, dear students, you solve the exercise 7a. Exercise 7a from your elements of mathematics books. Okay, elements of mathematics books. You collect this one, elements of mathematics. You collect this one and solve the exercise 7a. All the question you can now solve it. So this one about your continuity chapter, and next chapter we will discuss very soon. Okay, thank you.